Hi, I'm Salma Thalji, a research software engineer at TUM and a PhD researcher in neuroinformatics at the Max Planck Institute working on circadian neuroscience. I'm a third culture kid, born and raised in Saudi Arabia in the Aramco community, a unique international environment. I went to high school in Bahrain, then, partly inspired by the irony that my surname means snowy and I'd reached 17 without ever seeing snow, I moved to the US to study electrical engineering with a focus on biomedical engineering at the University of Illinois at Urbana-Champaign. After 2 years as a lecturer at the German Jordanian University, where I developed and taught biomedical signal processing courses, I moved to Germany for a master's in neuroinformatics and now a PhD while working as an RSE. My coding journey from assembly to R reflects how my relationship with code has evolved, from single-use code during my engineering studies to robust interoperable research tools. Influenced by the strong open science ethos of the lab I'm now in, I learned that the legacy of our work shouldn't just be papers, but sustainable software that others can build upon. As lead RSE on Glee, a project funded by Reality Labs and hosted at TUM, my role involves creating an interoperable system for data storage and light logging enriched with structured metadata descriptors to collate light exposure data collected across labs, devices, and environments. This infrastructure is built around the frictionless data specification, part of a wider open science community dedicated to interoperability and data reuse. Through Glee, we've built a global community of researchers and practitioners who shape the foundations of these standards. In circadian neuroscience, one critical biomarker is the dim light melatonin onset, or DILMO. It marks the rise in melatonin levels in the evening and is the key indicator of the timing of the body's central circadian clock. DILMO is used widely in chronobiology, sleep research, and light-based interventions. Estimating DILMO means pinpointing that onset time precisely. Existing methods for estimating DILMO are often subjective or inconsistent. An objective algorithm called the hockey stick method was introduced over a decade ago, but is only available as a closed-source executable. To address this, I developed DILMO-R, an open-source R package that implements the method transparently and reproducibly. Developing DILMO-R was a forensic iterative process. The original hockey stick algorithm was developed by a scientist who passed away suddenly, leaving behind only a journal paper describing the method at a high level and personal correspondence written colloquially. I reconstructed the algorithm from scratch, validating my implementation against the original executable to ensure identical output. Open sourcing the tool made it scriptable and scalable and laid the groundwork for a journal paper that's just been accepted, evaluating the algorithm's behavior under different conditions for the very first time. This experience reinforced my belief that open, well-documented code is essential for scientific progress. Coming into chronobiology just 2 years ago gave me a fresh perspective on its computational culture. The field often relies on ad hoc scripts with little focus on reproducibility or long-term maintenance. This is partly historical. Chronobiology emerged from biology, not software engineering, but the result is fragmented tools, undocumented methods, and poor reuse. My fellowship proposal is a direct response to that, bringing open, sustainable software practices into circadian science. My proposal focuses on two main goals. First, to develop open, validated, well-documented tools that are easy to adopt and reuse, and second, to foster a culture of collaborative open software development by teaching version control, documentation, testing, and community-driven coding. The aim is to turn isolated scripts into shared infrastructure. The core activity is a week-long workshop hackathon for early career chronobiologists from across the UK and EU that have basic coding experience in R. Day 1 will be held in a hybrid format with around 30 participants joining both in person and online. I'll introduce DILMO-R and we'll use it in real workflows. We'll discuss its strengths and limitations and brainstorm alternatives. This part of the workshop will be based on a vignette I've developed for showcasing DILMO-R functionality that I've used to train colleagues and collaborators. Days 2 to 5 will be fully in person, with about 15 participants working in small teams. These days are inspired by an RSE summer school I attended at KIT last September and will consist of morning mini-sessions on RSE fundamentals, followed by team-based hands-on coding sessions the rest of the day, where participants apply those principles in real time to prototype new DILMO estimation approaches. The goal by the end of the week is to leave having planted the seed of a shared culture of open, sustainable software development across chronobiology. Here's the plan in 4 phases. Phase 1 is for preparation of materials, expanding the DILMO-R vignette, drafting RSE mini-lessons, and preparing datasets. Phase 2 is the workshop, and Phase 3, I'll host bi-weekly remote check-ins to keep up hackathon momentum. Phase 4 is wrap up and hand off. We'll integrate code outputs into Dilmo R, publish a white paper detailing the experience, and release a reusable carpentry-style workshop kit. Fellowship funds will support travel grants, especially for UK participants with limited funding, as well as travel support for mentors and workshop catering. This work will deliver practical outcomes short term, while long term I hope to shift the computational culture in chronobiology towards reproducible, maintainable open tools. Our lab has existing close ties with several UK-based institutions and networks, and will leverage these relationships to recruit participants and potentially mentors and to disseminate the learning materials afterwards. This workshop will further foster research relationships between the UK and the EU and enable joint research outputs and transfer skills and tools into UK labs. The SSI Fellowship informational webinar I attended showed me an SSI community that is warm, generous, and good-humored. I'd like to learn from experienced fellows on how to design an effective carpentries course, get mentorship on sustaining a community of practice, and draw on SSI's reach to extend the impact of tools like Dilmo R's to a wider community. Thank you for your consideration.